In this lecture, we will learn about the proxy design pattern and how to implement it in Python. Proxy is a structural design pattern that lets you provide a substitute or placeholder for another object. It controls access to the original object, allowing you to perform something either before or after the request gets through the original object. There are many use cases for when we should consider using the proxy design pattern. When we have a heavyweight service object that wastes system resources by being always up, even though we only need it from time to time, we can use lazy initialization with a virtual proxy. If we only want specific clients to use the service object, we can use a protection proxy for access control. When we want local execution of a remote service, for example when a service object is located on a remote server, we can use a remote proxy. Proxies are also useful for logging requests. For example, if we want to keep a history of requests to the service object, we can use a logging proxy. To cache request results, we can use a caching proxy. This is useful when we need to cache results of client requests and manage the lifecycle of this cache, especially if the results are quite large. Proxies are also good for smart reference when we need to be able to dismiss a heavyweight object once no clients use it. Let's look at the advantages and disadvantages of using the proxy design pattern. Advantages of the proxy design pattern are that we can control the service object without clients knowing about it. We can manage the lifecycle of the service object when clients don't care about it. The proxy works even if the service isn't ready or is not available. And we can introduce new proxies without changing the service or clients. Disadvantages of using the proxy design pattern are that the code may become more complicated, since you need to introduce a lot of new classes, and the response from the service might get delayed. Let's learn how to implement the proxy design pattern in Python. Up at the top of the code, we will import random. Then we will create a class named information. Inside of this class, we will create a function named getInformation that takes in the self parameter. We will use the pass keyword in the function body. Next, we will create a class named secretInformation that extends the information class. Inside of this class, we will implement the getInformation function. Inside of this function, we will create a variable named codeNumber and set it equal to random.randrange, with 0 passed in as the first argument, and 99,999 passed in as the second argument. Then we will return codeNumber. Next, we will create the proxy class. Inside of this function, we will have a variable named secretInfo that we assign to an initial value of none. Then we will define a getSecretInfo function that takes in the self parameter, as well as a parameter named hasSecurityClearance. Inside of this function, we will first use the global keyword for the secretInfo variable. Next will come an if statement that checks the value of the hasSecurityClearance bool. If it is true, we will set the secretInfo variable equal to a new secretInformation object. Then we will return secretInfo.getInformation. Inside of the else statement, we will return -1. Time to test our code. We will create a variable named proxy, which we will set to a proxy object. Then we will create a variable named info, which we will set to proxy.getSecretInfo, with true passed in. Finally, we will print out the info to the console using Python's print function. When we run the code, notice that we got a randomly generated number as the secret information. In the next lecture, we will learn what a behavioral design pattern is.